Okay, we just saw how views, about the views. We just saw how we are going to use a view workplane tool, how we use the workplane tool, different functions like 1 point, 2 point, and 3 point. This thing now we are well aware of how we are going to use. So hope that is now pretty much clear to you. And we'll move on to the next topic. That is our next topic. That is grid placing. So here is a sample. This is a sample model to start with. It's a very pretty simple model. You can see only three columns are there. So just three grids, and this way two grids are there. So this is a simple model which we are going to start today for the lecture. So this grid we have to modify. Now we already have a grid here. We can modify it. These parameters we can modify it to match the design drawing. So this is how the design drawing looks when you are in the steel construction industry, oil and gas, or any commercial company. You'll find design drawings looking similar to what you are looking at right now. Okay, so something, this is just a sample. This is not the actual thing which is used on any company, but this is just a sample for our training purpose. Yeah, so the purpose of training, we have prepared this. Here you can see sample sheet for training only. Okay. But similar, this content will be similar to the company. Okay, in company you will find the same thing or similar. Okay, so we'll start with the process now of adding the grid. So this is our first topic, that is creating grid. So I will just take you to this topic, that is grid placing and creating a grid. First topic, that is creating a grid. Now creating a grid using Tekla is we are having a existing grid. So with the default grid which we have, we can modify it to match with our design drawing like this. So we can match it to the design drawing, or we can create a new grid. If you don't want this grid, we can delete it and we can create a new grid. So how new grid is created? You have to go to edit. In the ribbon tab, you have to go to edit and then just pan on the right side and you will see a grid here. Grid addition tool. Now here I have to create a create grid. Okay. The same parameters which were there in the previous grid, it will be visible to you. But we don't need this one. We need to modify it to look something like this. So in the X direction, you can see this 6,000, 6,000. So in the X direction, this is origin is 0. So I am assuming that this origin is 0. So first value will be 0. Second value will be, I will remove this and I will add 6,000. Okay. Then space. Space, like you would separate two spacing from a space. Okay. With a space. So that's why we are adding a space. So this is a separator. You have to separate two values with space. Okay. And then when I click enter on the keyboard, enter, you'll see it is combined automatically. 2 into 6,000. So that means 1 and 2. It is automatically combined into. Okay. Same thing. I will enter in y coordinate, y direction, the y coordinate for grade 1 and 2. So I have to check what is the dimension between 1 and 2, that is 8,000. So I'll select here and then 8,000 and then enter, click enter. So that parameter is created here. Now I have just created X and Y direction. Okay, so still this is balanced. Z direction, I have not added anything yet. So we are just going to add first, we are just going to add X and Y. Then later we will add Z direction. Okay. So in X direction, what are the labels? So in X direction, we have first label is A, second is B, and third is C. First means it is near to the origin. So near to the origin is first is A. Then next is B. Next is C. Okay. Same thing applies to now our origin is, we have assumed origin is bottom left. So this is left hand side, this is bottom side. So bottom side first is 1 and next is 2. Okay. Clear? That is, this part is clear. And this way we can add n number of grids in this direction, in this direction. It can be any numbers. Okay. I am just adding 2 grids because our sample is having 2 grids. But you can add many other grids. Okay. If your design drawing is having many grids, like it is a very big uh, project or a pipe rack, something like that, which is having many grids, different view, many columns are there. So we can add grids like which is matching to that particular model. Okay. So now I am matching to this sample model, right? So I will say here now X and Y is created. I will say here create. Okay. X and Y is there. According to X and Y, our grid is created now, but I have not entered anything in Z now. So now next thing I have to add in Z. Okay. So I have to select the grid first because I am going to modify it. I will not create because the grid is already created. So when I am modifying something, I have to click on modify, not create. What will happen if I create again? Because it is already there. If I click here, there will be a double grid on top of grid. Okay, so double grid will be there. So in order to avoid that, you have to click on modify because grid is already created. Now I will add the Z level, the Z levels, Z part. Now Z part, you will be able to see the Z part here. In the elevation, this is called the elevation view. This is called the plan view. Okay, base plate plan. You can see there are different plans shown here. So there will be like in GA drawing or the erection drawing, you will be having plan and elevations. Elevation is nothing but the side view. When you look from the side of this A, when you look from side, you will see this kind of structure. When you look at the plan, you will see this kind of structure. Okay. So now I will go here and I will check for the values here. Now it is the time for checking the values. Like there are values here, you can see 6,000, 8,000. Similar way, we need to check for the values in the Z direction. So this is the Z direction. Okay. And this is the left side. And this is the right side. Or the top side. Left side and the top side. Left side and the top side. Now you have to compare the grid numbers. Grid 1, grid 2. Grid 1, grid 2. That means you are standing here and looking in this direction. Okay. When you are standing here and looking in this direction, you will see one on the left, two on the right. Okay. So you are inside the building and looking at this structure. Clear? Okay. Now I have to see at the levels. Now by looking at the levels, I will understand this is FFL. This is some level is there here where there is a beam. Then another level is here. Another level is the top. But when I see at the level, now here there are two different levels are given. So what our metric is this one. This is a metric one. This is the imperial one. This is for the feet inches. Foot inches. Have you worked on foot inches? This is foot inches. So normally in US standard, will be having the foot inches. In US, they are using foot inches. Okay, and in our normal other worldwide standard, they are using metric. Okay, so you will see worldwide, you can see metric standards used. So you will get this kind of figures worldwide. But when you are working on a US project, you will be having this kind of figures. So this is just sample for if somebody wants to work on the US grids, you can use these figures. This is the sample figure for the US standard. Okay. So we have to just ignore this one. We have to look at the part, the metric part. I will just ignore this one and look at the part. Metric part is this one. Now 5, 10, and 12. Now here you can see there is one confusion like 6,000, 8,000, and here why there is 5, why there is 10. So if we are considering this as this is this is So what this value is actually? This can't be 5 because 5 will be somewhere here, actual 5. Okay. But what is this 5? Then if it is shown like this, then there will be some notes. You have to go in the notes. These notes are very important. Okay? You have to look into the notes. So in general notes, first point we'll see all dimensions are in Okay, all dimensions are in So this is this is this is What about this? We'll see here. Point number 2, all levels are in meters. So, okay, now it is clear. This is in meters. Okay, so how we have gone there in meters? I'll just show you. So 5 into 1,000. 5,000. So this is 5,000. 10 into 1,000. So 1,000 is like 1 meter is 1,000 mm. This is mm. Okay. So 10,000. Yeah. So if it is 20 into 1,000, 20,000. So I have to convert this in. Yeah, we have to convert this in mm. And then you have to enter these coordinates here. 5,000, 10,000, and okay, so it is already there. Just this we have to change 12,000. Okay, 5,000, 10,000, 12,000. So it is already there. Levels are already there. Only thing here I have to add 12 because this 12 should be matching with this one 12 meter. Okay, so this is in meters, 5 meters, 10 meters, 12 meters. So that is the reason we have shown here 5.00, 10.00, and 12.00. So we are going to add something here like small m, small m, small m to understand that this is meter. If somebody is there who don't know about this assumptions, then you can refer that small m is there. That means this is meter. So just for a reference, if you don't want to add, just remove the same and then generate the grids. This is not a requirement. Just for the understanding, we can add there m. But if you don't want, you can remove that. It's perfectly fine. So I'll just modify it here. Yes. And now you will have z coordinate set. Okay, so x, y, and z. Both the 3 directions I have set the coordinates now, and then I'll close this grid. And then I will do one thing here, like you can see here, the box is big. The view frame or the model view box is big. So I have to reduce, yeah, I have to reduce this to fit to the grid size or our model size. So what I will do, I will click here, okay, in the blank space, right click there, fit work area to entire model. Okay, click there, and now you see the entire area is now fit to the size of the grid. Okay, understood this? Yes. Okay, so now it is fit. So this way we are going to add a grid So this is clear. Addition of grid. You understood this?
Yes.
Grid addition. Now we are going to see sloping grid. Okay, create sloping grid. This part. Now I'm going to switch over to this uh, 3D to plan. So 3D to plan like this. Okay, now it is plan view. Now I want a sloping grid this way somewhere. Okay, somewhat say assumption. I will just assume it to be on 30 degrees. So I need a grid here. It will start from here and then other grids will be going this way, this direction. And it will start from here. So this is the origin and x direction is like this and y direction is like this. Okay. So based on this assumption or maybe in sloping case, in the case of sloping grid, you have to find out the origin. Okay, you have to locate that origin in the Tekla. So for now, I'm going to assume that the grid is starting from here because actual condition, as per the design, it might vary. So your grid might be somewhere here, grid might be somewhere here. Okay, it can start from here also. So we don't know the actual conditions. But now, for now, training purpose will be assuming that the grid is starting from here. So uh, I'm going to draw a construction line here and click here, and then click here. We provided 2 points to add a construction line. Then I will have to rotate that line. Okay. Move for rotating, right click, move special, rotate. Okay. Now I have to specify a point, origin point for rotation. So I will click a point here. I want to rotate from here. So that point is here now, 8,000, 12,000, and then rotation angle, say for example, 30. So I have to rotate it from 30 degrees from this object. So I will say simply move. And once I move, you can see the construction line is rotated. Okay. And just click OK here. And then I go to second option, that is this X direction. I need a Y direction in this way, 90 degrees to this. So copy special, rotate, click on the origin point here, and then I need 90 degrees to this one. So this is already in 30 degrees. So I have to add here 90 degrees. So 90 degrees will give me a Y direction. Okay, here like this. Did you got it? Understood? Yes. Okay, first step, I had drawn a line here. Then next step, I have rotated it to get this 30-degree angle. And now I'm going to measure it, verify. So we have to verify that it is correct or not. How it is done? Measure, angle. Okay, so to go in edit. In edit, you have to go to measure and angle. Okay. In angle, I have to select one point, origin, and one direction vector, another direction in this one. So it will give me the degree of that particular object. So this is the degree of this length from reference to this. Okay. So now it is confirmed. This is 30 degree. It's confirmed. This is 90 degrees. You can confirm it like this. 90 degrees. Okay. So we have now confirmed our uh, this thing. Assumptions of the construction line is now in the correct position to add the grid. Now we will proceed forward for adding the grid. I'll go to edit and go to the extreme right corner till you see the grid. Okay. Now, before going on to grid, we have to first set the work plane. Right? So in the last session, we saw how we are going to set the work plane. Now here we will use the 3 point origin XY, or we can use this also. Okay, 2 point for X direction. Okay, so I will use this one, 2 points, origin and X. Okay, did you
Yes.
understood this?
Yes.
So I got the uh, work plane to set like this in 30 degrees. Okay. Now I will go to grid, edit, then go to grid, create grid, and simply click on create. Say I don't want to, I want to just add the same grid which is there here. So, or if you want to load any standard grid, I'll just load that grid and then create. Say create. Then see the grid is created in slope. So slope is actually reference to this uh, local work plane. So local work plane is rotated. So according to that, your grid will be rotated. Okay, you understood this? Any doubts here?
Yes.
Hmm? Mhm.
Understood.
Now I need to set this to the original location, that is view, work plane, and this one. So with this work plane to XYZ means it will set to the original location here. Okay, so local plane will match the global plane here, this way. Now it is gone from here, and we can modify this now to whatever we dimensions we need. We can go here and modify, then modify the dimensions to match it with the design drawing. So whatever dimensions you are going to use in the design drawing, so same dimensions can be matched in this grid. Now, okay, we just these temporary dimensions we can redraw, view, and it will be gone. Okay. Now sloping grid is clear. Now we'll go for the next thing, that is create grid views. Now create grid views. How we are going to use this tool? I'll just show you. For create grid views, I have to select a grid first. Right click, create views along grid lines. Okay. You have to uh, call this dialog box. So how it is done? First, you have to select the grid. Right click, create views along grid lines. Okay. There is another way. New view along grid lines. This can also be done. Okay. From here also you can use that along grid lines. Hmm? So when I click on create, you can see grid views are created. So when I go here, you can see the levels are created. Huh? Whatever we entered in the grid, it is created there. Okay? The levels, you will be able to see the levels. Okay.
Okay, sir.
Oh, sorry. You're there. Okay. So this is a way we are creating the grid views. Okay. So you completed this part also. These are the views. You can open it. Okay. So now this way we can create a grid views. Okay.
Yes.
So think this will end the topic of grid placing for today. So we are going to end the topic today. Okay. We'll then continue in the next lecture with grid placing. Okay, we'll start with this topic in the next lecture. Okay.
Next lecture.
Okay, we'll end the lecture today. Okay. Thank you.
Thank you so much.